Newton's first law states that a body remains in rest or in motion with a constant velocity unless it's acted on by an unbalanced force. After the ball hits the racket, it travels across the court resisting change in motion or inertia. But when it hits the net, it creates an unbalanced force, creating the ball to stop. Newton's second law explains how an object will change velocity if it is pushed or pulled. First, we calculate the acceleration of a serve by dividing the change in velocity, which is 54 meters per second, and the time, which is 0.3 seconds, making the acceleration 180 meters per second. Then you plug it into the formula, which is F equals ma, which is force equals mass times acceleration. So then, for the force, you get 180 times 0.4 kilograms, which is equal to 72 newtons. Newton's third law says that every action has an opposite and equal reaction. During the backboard, when the ball hits the wall, it exerts a force on the wall. The ball returns an equal force in an opposite direction that pushes it back. In topspin, the friction between the racket string and the ball is used to make the ball spin forward towards the opponent. When the ball is in the air, a thin layer of air is rotating with the ball, which means the velocity below the ball is faster than the velocity above the ball. Also, pressure below is lower than the pressure above the ball, causing the ball to fall sooner. Using backspin requires only half the racket speed compared to hitting topspin, because the player is not required to change the direction of the ball spinning. In backspin, the same principles are in action, except in this case, the bottom of the ball has a lower velocity, so the pressure is higher, thereby causing an imbalance in force that pushes the ball up.
This picture shows how the ball moves.
Law of conservation of momentum states that the momentum, mass times velocity, before a collision occurs is the same as after the collision. The formula is mass of the ball times velocity of the ball plus mass of the racket times velocity of the racket equals mass of the ball after the collision times velocity of the ball after the collision plus mass of the racket after the collision times velocity of the racket after the collision. The moment the racket and the ball hit before the collision is the same after the collision. Kinematics is the study of motion. When the ball is in the air during a tennis serve, air resistance and frictions lessens about 50%, making the ball start off at about 120 miles per hour and ending at the opponent at 65 miles per hour.
This graph shows the kinematics in a serve.